Have you ever wondered why Uranus and Neptune have different colors? You may have seen images of these planets before and noticed that they have different shades of blue. Uranus is usually shown as a pale greenish blue, while Neptune is a darker and more vivid blue. But did you know that these images are not accurate and that both planets are actually very similar in color? In this video, we will explain how a new study used advanced techniques and data to reprocess the images of Uranus and Neptune and show us their real colors for the first time. This study reveals new information about the atmospheres and climates of these planets and challenges some of the previous theories and hypotheses. It also raises some new questions and opportunities for future research and exploration. So if you are curious and excited to learn more about this topic, then stay tuned and watch this video until the end. Uranus and Neptune are the 7th and 8th planets from the Sun, respectively. They are both classified as ice giants because they have a thick layer of icy material surrounding their rocky cores. They are also both very cold, with average temperatures of about -200 degrees Celsius. However, despite their similarities, they have always appeared to have different colors in the images we see. Why is that? The main factor that affects the color of a planet is the composition of its atmosphere. Uranus and Neptune both have atmospheres that are mostly made of hydrogen and helium, but they also have a significant amount of methane gas. Methane absorbs red light and reflects blue and green light, giving the planets their blue-green hue. However, the amount and distribution of methane varies between the two planets, and this affects how they reflect light. Neptune has more methane, and it is more evenly distributed throughout its atmosphere. This means that Neptune reflects more blue light and appears bluer. Uranus, on the other hand, has less methane, and it is more concentrated in the upper layers of its atmosphere. This means that it reflects more green light and appears greener. But there is another factor that affects the color of a planet, and that is the way we process the images. The images we see of both planets are not raw, but processed by various instruments and software, which can introduce errors or biases. For example, the most famous images of these planets were taken by Voyager 2, a spacecraft that flew by them in 1986 and 1989. However, the spacecraft had limited resolution and color accuracy, and the images had to be enhanced and calibrated by scientists. This means that the images we see may not reflect the true colors of the planets, but rather the limitations of the technology and the choices of the scientists. In fact, some of the previous studies that tried to explain the color difference between both planets used these images as their basis and came up with different hypotheses, such as the presence of other gases, clouds, or storms in their atmospheres. However, these hypotheses were not conclusive and had some problems or inconsistencies with the data or the observations. So, how can we find out the true colors of Uranus and Neptune? Well, this is where the new study comes in. The new study is the result of a collaboration between astronomers from the University of Oxford and the European Southern Observatory. It used data from two of the most powerful telescopes in the world, the Hubble Space Telescope, which orbits the Earth, and the Very Large Telescope, which is located in Chile. They also used a sophisticated model of the atmospheric layers of both planets, which simulates how light travels through them. They reprocessed the images of Uranus and Neptune taken by Voyager 2 using the data and the model to correct for the errors and biases. The result was a stunning revelation. Both planets are actually very similar shades of greenish blue, and the difference in color we see is due to the difference in opacity of a layer of haze and methane ice in their atmospheres. The study found that Neptune has a thinner layer of haze, which allows more sunlight to reach deeper and be absorbed by methane gas, making the planet slightly bluer. Uranus, on the other hand, has a thicker layer of haze, which blocks more sunlight and reflects more green light, making the planet slightly greener. The study also showed that the haze layer varies with latitude and season, and that this affects the color and brightness of the planets. It also compared the reprocessed images with the images taken by the Hubble and the Very Large Telescope, and found a good agreement, confirming the validity of the results. They also provided some of the most detailed and accurate images of Uranus and Neptune ever seen, showing their features and structures in high resolution and color fidelity. This study is a remarkable achievement and a major contribution to our knowledge of Uranus and Neptune. It shows us that these planets are not as different as we thought, and that they share a common color and origin. It also shows us that their atmospheres are complex and dynamic, and that they change with time and location. But what does this mean for our understanding of these planets? And what are the implications and significance of this study? This is what we will discuss in the next section. This has several implications and significance for our understanding of these planets, and for the field of planetary science in general. Here are some of the main points. It confirms that methane is the main factor that determines the color of Uranus and Neptune, and that the difference in color is due to the difference in haze thickness. This means that the previous hypotheses that suggested other factors, such as the presence of other gases, clouds, or storms, are not supported by the data. This also means that the atmospheres of both planets are more similar than we thought, and that they have a common origin and evolution. The new study also reveals that the haze layer of Uranus and Neptune is variable and dynamic, and that it affects the color and brightness of the planets. This means that the atmospheres of both planets are not static, but change with time and location. This also means that the climate and weather of these planets are more complex and diverse than we thought, and that they have different patterns and cycles. For example, the study found that the haze layer of Uranus is thicker near the poles and thinner near the equator, and that this changes with the seasons. This could explain why Uranus has a more extreme seasonal variation, and why it has more storms and winds than Neptune. The new study opens up new possibilities and opportunities for future research and exploration of both planets. It shows that we can use more advanced telescopes and spacecraft to observe and study these planets in more detail and depth, and that we can use models and simulations to interpret and analyze the data. It also raises some new questions and challenges, such as what causes the variation in the haze layer, and how it affects the climate and weather of the planets. It also inspires us to wonder and appreciate the beauty and diversity of our solar system, and the secrets and surprises it still holds for us. We hope you enjoyed this video and learned something new and exciting. If you did, please give us a like and subscribe to our channel for more videos like this. Also, feel free to share your thoughts or questions in the comments section below, or check out the resources we used for more information. Thank you for watching, and see you next time.